Namaste student. Today we are going to discuss about one of the most important topic in this chapter, that is metals and non-metal. Today our topic is occurrence and extraction of metals. Okay. First topic is your occurrence of metals. Occurrence means we are talking about how they are found in nature. So metal generally they are found in two form. One is your mineral form, another is your ore form. Now let us see what are minerals. The element or compound which occurs naturally in earth crust are called minerals. Now what are called then ores? Those minerals which contain very high percentage of particular metal, and metal can be profitably extracted from it. Such minerals are called ores. Example, rock salt, that is the ore of your sodium, bauxite, that is the ore of your aluminium, hematite, that is the ore of your iron, and galena, that is the ore of your lead. So among these you will find that all ores are minerals, but all minerals are not ores. Okay, so beside these ores there are many other minerals of particular metal, but most of the cases you will find that only one ore of metal is there for its extraction, because that is the best method of cheap extraction. Now the next topic is types of ores of metal on the basis of reactivity. So on the basis of reactivity, the ores are divided into three categories. One, metals at the bottom of the activity series, or you can say least reactive metals like gold, platinum, silver, copper generally occurs in free state. Means they will not exist in compound, but what happen, you see, copper and silver can also occur in sulfide and oxide ore. Okay, why? Because they are slightly reactive, so they will react with either sulfur or oxygen and form their corresponding sulfide and oxide. Example of this type of ores are mercury sulfide, this is known as copper sulfide, this is copper cuprous sulfide, silver sulfide, etc. Okay, now the next type of ore is your metals of reactivity, medium reactivity. These metals include zinc, iron, lead, etc. Occurs mainly as oxide, sulfide and carbonate ore. Example, zinc sulfide, lead sulfide, zinc carbonate, etc. Okay, now the third type of ore is metals of high reactivity like potassium, sodium, calcium, magnesium, aluminum, and they are very reactive and thus found in combined form in the form of halide or oxide. Example, sodium chloride, aluminum oxide, magnesium chloride, calcium chloride. Okay, so based on the chemical reactivity, metals ore are divided into three types. One is less reactive metal ore, more reactive metal ore, and medium reactive metal ore. Okay, now let us see how these metal are extracted from their ores. The stepwise process of extraction of metal from its ore is known as your metallurgy. So combine sum total of all the process from the extraction of metal is known as your metallurgy. It generally involves mainly three steps. Okay, first is your step 1, enrichment or concentration of ore. Now the second step is extraction of metal from its enriched ore, and the step 3 is refining of impure metal to obtain pure metal. In this class we are going to discuss about the enrichment or concentration of ore and extraction of metal from their enriched ores. Okay, so let us come on to the first topic, that is enrichment or concentration of ore. So these are the three terms that is commonly used in this enrichment. First is your gangue. The ores are generally contaminated or polluted with large amount of impurities such as soil, sand, etc. They are known as gangue particles. Okay. Now what about roasting? The sulfide ore are converted into metal oxide by heating strongly in the presence of excessive air. This process is known as your roasting. Okay. The reason behind it is because it is very difficult to extract metal from its sulfide ore as compared to oxide ore. Now what about calcination? The carbonate ore are changed into oxide by heating strongly in the limited supply of air or absence of air. This process is known as your calcination. Okay, so now let us move on to the next step in extraction of metal, that is extraction of metal from enriched ore. Okay, so based on that there are three methods of extraction of metals. The first is extracting metals low in the activity series. Example, copper, silver, gold, mercury. Okay, these are the very low reactive metals. So these metal can be extracted by this method. In this process, what happens? The ores are heated in the presence of air at a very high temperature. Okay, so here there are two methods of extraction. One is for mercury, another is for copper. So mercury is extracted from cinnabar ore, and which is known as your mercury sulfide. When the cinnabar is heated in the presence of oxygen, the process is known as roasting because this is a sulfide ore. So it will form mercury oxide and sulfur dioxide will be evolved. Now mercury oxide, when it is strongly heated, it will undergo decomposition and it will produce mercury liquid form, along with there is evolution of your oxygen gas. Okay. Now the second is copper is extracted from your copper glands ore, or the chemical name of this is copper sulfide. Now when the copper sulfide is heated in the presence of oxygen, the process known as roasting because this is a sulfide ore, so copper oxide, again there is formation of sulfur dioxide gas. When these copper oxide react with the remaining copper sulfide, they will reduce each other. Okay. And they will produce copper metal in liquid form, and there is evolution of your sulfur dioxide gas. And since here both the copper species reduces each other, this process known as auto reduction. Okay. Now let us move on to the next type of extraction of metal, that is extracting metals in the middle of the activity series. Okay. Here the metals like iron, zinc, lead is extracted. Metals are easier to obtain from oxide ore than sulfide and carbonate ore are converted into metal oxide. Okay. First, metal carbonate ore are heated strongly in the excess of air. This means when the sulfide ore is there, when it is heated in the presence of oxygen, this is known as roasting. It will form metal oxide and there is evolution of your sulfur dioxide gas. What about metal sulfide? When the metal sulfide ore are there, it is strongly heated in the limited supply of air, or you can say absence of air. This process is known as your calcination. So you see zinc carbonate, when it is heated, it will produce zinc oxide and carbon dioxide. In both the cases you will see that. In both the cases you will find that always metal oxide will be formed. Now here this method will not stop here. It will move on to the next step, that is reduction of metal oxide to metal. First is by using coke. Coke act as a reducing agent, so it will reduce zinc oxide, react with this coke and form zinc, and carbon monoxide will be evolved, and this process known as your reduction process. The next way of extracting metal from metal oxide is using displacement reaction. Highly reactive metals like sodium, calcium, aluminum can be used to displace metals of low reactivity from their compound. For example, manganese oxide when react with aluminium, what happen, this aluminium will replace manganese from its manganese oxide, and the manganese will be liberated and the aluminium will form aluminum oxide, and there is evolution of heat. This kind of reaction produces a lot of it. Okay. Now the third type, that is extracting metals on the top of activity series. For example, metals like sodium, potassium, magnesium, calcium are extracted by this method. These metals have a strong affinity for oxygen than carbon atoms, hence they are obtained by electrolytic reduction of this molten form. Okay, when they are electrolytically reduced in their molten form, then these metals will be obtained. For example, sodium is obtained by electrolysis of its molten sodium chloride. You see, when the sodium chloride is strongly heated, what happen? It will change into Na plus and Cl minus ion in molten form. Okay, as electricity is passed through this solution, metals get deposited at cathode and non-metals at anode respectively. You see the chemical reaction at anode, what happened? There is a reduction reaction. The sodium will accept one electron and form sodium metal. At anode there will be oxidation, where you will see that chloride ion will accept, lose two electron and form chlorine at a molecule, and there is a evolution of your two electrons. Okay. Now here are the questions based on the topic that we discussed today. Please go through the questions and write the answers of this question in your homework notebook. Thank you.